So next chapter we need to understand about the gradient descent. So the word meaning gradient we have to understand properly. The gradient descent is first order iterative optimization algorithm for finding the minimum of a function. What is now gradient descent? It is an algorithm. What is this? It is one algorithm. To do what? To find the minimum of a function. Minimum of a function. Suppose I written one function that is known as f of x is equal to 4x power 4 minus 3x cube plus 2x square, okay, plus x is equal to, okay, plus x plus c is equal to 0 something I written. Sorry, not 0, plus c I written. What is now? It is a function. What is the minimum value of this one? I want to understand. Generally, to get the minimum value, what we will do is we'll try to differentiate it and we'll equate to the 0. Then whatever result we are getting it, that is what we'll say minimum value. Said that, for example, let me take one simple one. We are trying to take it. F of x is equal to, I am taking as x for 4, 4x for 4, like this we take it, minus 3x square, we take it, like that's it. Can you tell me what is the differentiation of this one? What is differentiation? General differentiation means f dash x will say. What is differentiation of this one? 16 x power cube minus 6 x, right? Then differentiation whatever value is available will make it as 0. 0 is equal to now 16x cube minus 6x. So x we are taking the common, then and it's going to 0. Then we'll get here 16x square is equal to 6. Then x square is equal to, we have here 3 by 8. So x is equal to root of 3 by 8. Whatever value you get it, that is what the minimum value. So to get the minimum value, what are you supposed to do? Just differentiate the given function and make it to the 0, equate to the 0, then whatever value you get it, that is what the minimum value. That is what the minimum value. To calculate this one, sorry?
You initially wrote a function and below that you written a different function at 16x cube minus.
Right, it may be any function. It may be any function. Just simply I taken two functions I taken.
Okay.
It is a different function.
And making it to 0 and find out the x value. That is what you saying?
Yeah, find out the x value, and after differentiation, whatever x value you are getting, that's what the minimum value for that function.
Okay.
That is automated using the functionality called as gradient descent. To automatically calculate that minimum value, the gradient descent algorithm is useful. So if I give any function as input to this gradient descent algorithm, that will do the differentiation, that will equate to the 0, that will calculate for us what is the minimum value.
What do you mean by differentiation here?
Derivatives. Derivative. Normally we have in the mathematics, derivatives are available, right? The derivative.
Okay.
Yeah. Now, next point is here, to find a local minimum of a function using the gradient descent, take steps proportional to the negative of the gradient. What is the meaning of this one? We have to understand it. To find local minimum of a function using gradient, one takes steps proportional to the negative of the gradient or approximate gradient of the function of the current point. Let us focus on that line. We'll try to speak about that now. For example, you see this one kind of illustration kind of thing is available. Suppose I am available at this point, let us say. I am available at that point. It is a dark room. It is a fully dark. It is night time, let us say. Night time, and I am available in top of the illustration. I am available. My goal is I want to go to the minimum point. I have to go. Minimum point means where it is available. Here it is available, right? So my goal is go to the minimum point. I said already, it is night time. I don't know. I don't know which side is the height is growing, which side is the height is decreasing. I don't know. But still, I have to go. My target is I have to go to the down. How I will go to the down? So this is my first leg. This is my first leg, and I'm putting here my second leg here. I'm putting it. This is my second leg. First leg to second leg. Can you calculate the slope? Can you calculate the slope? Yes. For example, at the first leg level, I have the x-axis value, y-axis values. I should have, right. That, for example, let us assume like that. X-axis value we have here. X-axis value we have here some 7, and y-axis value we have here some 9. At this point, what is the x-axis value and y-axis values are somewhat decreased or not? Both are decreased. So x-axis value is what here? At this moment I can say some 6, and at this moment I can say some 8. Yes or no? First leg to second leg slope I am calculating. First leg to second leg slope I am calculating. The slope formula, you people are very well aware of it. M is equal to y2 minus y1 by x2 minus x1. y2 minus y1 means what? 9 minus 8. How much? 1. By x2 minus x1 is what? 7 minus 6. How much? 1. So slope is equal to what we got? 1. Slope is equal to what we got? 1. Now read this point again. To find a local minimum of a function using gradient descent, one takes steps proportional to the negative of the gradient. Negative of the gradient of the function at the current point. Okay. So now whatever we have the value, the moment we are getting here positive means we will not put our leg towards the height side. We will put it towards the decreasing side. That's what the negative of that one. As long as we are getting the slope is equal to positive means what? We are going down direction only we are going it. Slope is positive means we are going what direction? Down direction we are going it. Positive and down are opposite. Positive and down are opposite. Slope we are getting negative means what is that meaning? We are not going down direction, we are going up direction we are going. That's how I will come to know, even it is in the dark room, if I have the slope value between first leg and second leg, what is slope value I have it, I come to know I am going in the up of the hill station or down of the hill station, I come to understand. Okay. This exactly opposite point is second one. If instead one takes steps, proportional to the positive of the gradient, one approach is what? Maximum of the hill station. That means this peak point we are going to reach it. Are you getting my point? Now we have one word is available now, slope. What is the word I introduced here? Slope. In our machine learning, the same slope is called as gradient. So if I say gradient or if I say slope, both are one and same. Wherever if I say gradient, wherever I say slope, both are one and same. The slope calculation also, this algorithm only will do for you. Don't worry. Gradient descent is algorithm name. Gradient descent is algorithm name. So gradient is equal to slope. So slope words I may not be using down the line in our program. I will be using down the line gradient word I may be using the program. Wherever I use a gradient, that means what? I am calculating the slope based on the inputs and weights. I am calculating the slope.
Normally descent was no slope.
Yeah.
So that's the reason he is asking.
Right.
Right. Sir, can you please explain that once again? So the minus slope was going upward and positive slope was going downward. That part alone.
Okay. No, nothing much. Slope is we got the positive. That means we are reaching the hill station downwards.
How do you know that?
That's what I calculate here, right? See, this is the first leg I said. This is the second leg I said. First leg to second leg, I calculated the slope. Then I got the positive. And you know real value, right? I'm first. This is the first leg. This is the second leg. You know real value. Tell me. You tell me. I'm going downwards. I'm going upwards.
Sir, instead of telling like that, you can explain him that y2 minus y1 is positive or negative. Based on that, you will know the slope value, right? So just tell him that the difference is positive or negative, right? You just calculated m equals to y2 minus y1 by x2 minus y1.
Right.
So, right,
The
so
magnitude also we need to know how much steps we are taking it. That is actual formula is m is equal to slope. You have to calculate it.
right.
That's what I went for the actual calculation. Okay. Let us move on to
If the slope is curved, then we'll go down, sir. So if that is the case, sir, what are we trying to find here, sir? Whether we are going down or going up?
yeah, that's it.
Slope?
That's it. Based on the slope, we are trying to understand whether we are going for the down direction or we are going the up direction.
Okay.
Now, we are trying to take here some more layman terminology. We'll try to understand this one. Very nice wiki it is. Let us go try to see this wiki layman terminology. Okay, this is what the illustrations are now. Are you seeing anything here? Everything is dark here. Everything is dark. We are not seeing properly what is there in the next feed. So just try to read this one. The basic initiation behind grade descent can be illustrated in a hypothetical scenario. A person is stuck in the mountain and is trying to get down. That is trying to find the minimal point is trying to find out. Down station is trying to find out. There is a heavy fog such that visibility is extremely low. Therefore, the path down the mountain is not visible, so you must use local information to find the minimum. That means what? You'll put the leg and all the directions you'll put it. Yes or no? First leg will be strong. First leg will keep strongly you'll keep it. Second leg you'll put in all the directions you'll put it. Wherever it is available down direction, that side you'll try to move it. Yes or no? Are you getting my point? You have to feel. You are putting the legs like that, then only you'll understand. Now, method of grade descent, which involves looking at the steepness of the hill at its current position. Then crossing the direction with the steepest descent. Steepest descent is the one more mathematical equation actually. Steepest, if you type only the word steepest, if you type it, then that is also one mathematical formula. Based on that one, this grade descent is actually derived. Okay, we did not go for that details. Overall, what we are trying to move, down illustration, we are trying to move it. By observing the second leg, we are testing in which direction the slope is coming positive. If you was trying to find the top of the mountain, for example, you want to reach to the top of the mountain, then where will go? Maximum point, we'll try to push it. That means slope should be negative. Like that, we'll try to move on it. Just in the free time, I request you people to study this material in the layman terminology. Next one we have here gradient descent, mass and coding from the wiki. Coding from the wiki. The gradient descent is an algorithm I said, right? The algorithm actual backend code what it is available. I want to know. Now I am giving one function to you. Let us go for directly the coding and mathematics. This is a function what I given to you, sir. What is the function? For example, what is this function? F of x is equal to x power 4 minus 3x power cube plus 2 I given. What is the function? X power 4 minus 3x cube plus 2. What is the differentiation of this one? X power 4 means 4x cube minus 3x3 means what is this? 9x square, and the constant derivative means what? 0. This is what the differentiation. And I said derivative we have to make as 0 to calculate the minimum point. We make it as 0 now. Then you try to solve this one, x square will go as a 0, then 4x is equal to 9. That is x is equal to 9 by 4. That is around, we'll get the 2.25, we'll get it around 2.25, right? 9 by 4 means how much? 2.25. Now I'll give the same equation to your hand. You write the now Python code to find out the minimum value. Whatever code you are going to write it, that's what called as gradient descent algorithm. That's what called as gradient descent algorithm. This is now what called as gradient descent algorithm. I'll explain this program. What you are trying to say is, first, we don't know which is the minimum value, right? Are you getting my point? I have the function, but I don't know what is the minimum value. I don't know. I'm assuming the minimum value is what? 6. I'm assuming it. What is my assumption? I'm assuming the minimum value is 6. I'm assuming. Then gamma is nothing but how much length of the step you have to take it. How much length of the step you have to take it. Always when you are in the dark rooms or dark illustration, you take the long step or you take the small step. Small step only you take, right? Long step you will not take it because we don't know what is there. That's the reason always the gamma value will be very small. It may be 0.01 or 0.1, 0.0001 also. Two small step also makes our program has to run so many times. Two small steps are taking means what will happen? To reach the down station, so many steps I have to put it or not. So we have to take the step size is optimized step we have to take it. It should not be too long. It should not be too small. If you take too long also, there is a one more big problem will come into the picture. What the big problem is? Suppose I am available, my first leg is here, sir. My first leg is here. If I am taking the long step and I am putting my leg here, then what will happen? I am losing what? Real minimum point I am losing it. Real minimum point I am losing it. That is the reason we have to take the step size as small as possible. As small as possible. But with the small steps, what is the one problem we have is we have to put more times, you have to put the steps. That means performance issue will be there. Okay. Now coming to this program now, we take in the step size is equal to how much? 0.01. Mathematically, the step size we are saying as gamma. Next is precision. Precision meaning up to how much accuracy I want to move. Up to how much accuracy I want to move. That is what called as precision. The step size whatever available, I am going to up to what level I have to take it. What is the minimum point? That's what called as desired precision we are taking. How many times you want to run this program? 10,000 times I want to run this program. Now we wait for the lambda functions. Everyone aware of it, lambda functions? Same equation. What is that? X power 4, right? Sorry, not x power 4. 4x cube, right? What is this? 4 into what is this? X cube minus 9x square. That's what the program. This x value we are going to get in the runtime. We are going to get it. We are doing the differentiation. We are doing it. There is reason df we written. It's not the data frame. It is a derivative. It's a derivative function. Derivative function means df we written. Now,
Maximum iterations is nothing but steps.
yeah, maximum iterations is nothing but nothing but number of steps. Number of steps you can take it. In our case, number of times our program has to run. For loop has to run. For loop I in range of max iteration. Now current x is equal to what we taken minimum value 6. We are assuming like that. Then next x is equal to current x minus gamma into differentiation of current x. Meaning, what is the meaning of this one? Can you substitute this? Can you calculate this piece? Substitute here. If you substitute, what is the value of the next x now? Next x is equal to 6. That means my current x is equal to 6. That means my df of x is equal to 6. We'll get here 4 into x cube. That means what? 6 cube. 6 cube is how much? 36. 6 sir. Quickly calculate. Very tough. Very tough. 216. Okay, I am putting 216. Minus 9 into x square is nothing but 36. You have to calculate this much. Once you calculate this one, we are multiplying with what? Gamma. Gamma means what is the value? 0.01. Whatever value we got here, this value we are multiplying it, and that we are subtracting from where? Current x. That means what? 6 minus. Can you calculate this one for one time? I am going to the Excel. Let me calculate this one. So I am trying to take here Excel. Then, so what is the equation I want here? Is equal to, I am writing here, what is the equation? 6 current x minus 0.01, okay, into, then what I have to write it? 4 into, what is that? 216 minus 9 into 36. This is what I have to do, right? No, not here. Here bracket. So we are trying to put the bracket here. The value, whatever we are getting, what is the value we are getting? Wow, 6 to 0.6 we decreased it. Our assumed value is what? Minimum value we are assuming like 6 is our minimum value we are assuming. But in the first step itself, too much we are able to reduce the minimum value to the 0.6 we are assuming. Are you getting my point? That 0.6 we are trying to subtract here from 6 minus 0.6 how much? 5.4. The 5.4 is the step next step we are trying to take it. Am I clear? Now we are trying to make sure the step size is not less than this much. The step size is going than this one. Then we are thinking like, okay, that is accurate point. Are you getting my point? Once I reach to the downhill also, within the downhill itself, there may be slightly slope may be available. Slightly slope may be available. Based on the slight slope, I need not put the feet. I am available here or I am available here also same, right? That step size is less than this one, then we are stopping the program, we are breaking the program. That's what this algorithm, what it is doing. Let's take this program as is, then try to execute it, then we'll get so much clarity. I'm taking this one.
The function is running based on this code.
Exactly. Now let me take here some new notebook. This is what they called as gradient descent algorithm means, nothing much. So let me execute this one. If I execute here, what is the minimum point we got it? 2.249. Our mathematical equation what given? Tell me. 2.5, right? 9 by 4. 9 by 4 means what? 2.5. 2.249 is equal to 2.5 or not? Yes or no? That means this program is calculating the minimal point or not? The minimal point. If you are interested to see more values, you want interested to see it, then write here each time what is the value of this next x, you try to write it. And each time what is the step value, also try to write it. Let us say next underscore x value, I am interested to see it. Write some print statements here and there so that you come to understand what is the values are happening here, right? So I am putting here step size and what is the step value I wanted.
Before and after print statement. Before step you have to give one.
Before step, invalid syntax next underscore x.
Sir, comma.
Next, before next. Print statement.
Oh, okay, okay. These commas are missing. Okay. Now you can see first time it went for how much value next x is equal to 0.59999. That is nothing but that's what our 6 is equal to. 6 means it's taken 0.599 something it is taken here. Now the next x once after calculation of this one, what is the value we got it? Next x value 0.59. Then step value becomes what now? Minus 5.4 it happened. Then is it executed really 10,000 times? Not executed really 10,000 times. Somewhere it is broken actually. That's what we are not seeing it 10,000 times. We are not seeing it. After these many steps, automatically it is broken and is giving as minimum value is what? 2.2. So what is the step size at the minimum value level? 8.9 is the step size it is taken. This is a step size. And what is the minimum value? 2.24. So this algorithm, whatever available, this is what I am calling it as gradient descent algorithm. Tomorrow I didn't given the function is not the x power 4 minus x cube plus 2 is equal to 0, not given. Something else equation I given. For something else equation also, can you write this program or not? That's where the actual gradient descent will come into the picture. For any function, this will work. This program works only for what? This program is working at this point of time only for what? 4 into x cube minus 9x square. But they written the gradient descent algorithm in such a way it works for any function. It may be x power 5 plus x power 4, something you are giving, still it works. More robust algorithm it is available.
Sir, one last question to understand the output. So you said the step at the step 8.98, it was broken and gave the minimum value. So
It's not
you
exactly
gave
8.98. It's a e power minus 06 is available. That means it is 0.00005 zeros. Okay, then we have the 8. This is what the minimal point. This is the step size.
Okay, so we were given the step size like the 0.01, right? It is the difference between each step we have given, very small steps we have given, right?
That's what we taken. That's what we
Yeah,
taken
that is the
initially.
interval we have given, right?
Yeah.
So it started from where? What is the starting point for this step?
Okay. So the starting step size we are trying to calculate it based on this gamma value. This gamma value only we are not fixing here always. Gamma value is one of the function based on the differentiation value.
Okay, so gamma value does not mean the step difference is 0.01. Gamma is something different. That's what you're saying. Gamma is not the
No. Yeah, that's right.
multiplier.
Gamma is not exactly the step size. The step size multiplier.
I see. Okay.
Okay, that always you are not taking the 0.01 only. Okay, 0.01 of whatever ever we have the error component.
So the end value, what we are proposing is the step size must be as small as 2 point something.
No, minimum point. That means the function is the minimum point. Let us say the function, if we put the dots like this, we got it. The minimum coordinate here we are saying as this is what the 2.2 we are saying it.
Okay, I got you. But gamma is not the step difference, it is the step
Right, gamma is
difference
helping you to put the feeds one by one. Feeds you are going to put it. That too, this step to this step value is not 0.01 exactly. This 0.01 is the multiplier actually. Multiplier.
Right.
Yeah.
Understood.
Yeah.
Okay, sir.
Reducing from the origin.
Yeah, reducing from the equation result what we got it basically.
Here, you have taken the equation x was 4x cubed
Yeah.
minus 9. So this is the standard equation.
No. That's what I said. This is not the standard equation, sir. This is one of the example wiki what we maintained. Our gradient descent is more robust. For any function, it will works.
So is there any
S. We have that. There is no defined equation. Just a general. What is the definition we studied about it, right? Let us go and try to see the definition again. We studied the definition. Where is the definition? We studied the definition here at the beginning. What is the definition we studied? It may be any function. The function in our case is what? Some we take x power 4 minus 3x square is the function what we taken. Okay? That function may be any function. Any function, if I take the graph paper, if I provide the x values 0, 1, 2, whatever values are providing, if you connect those all dots, then we get our graph. In that graph, what is the minimum value? To find out that one, we are following this process.
The equation part, every time,
Every problem will have its own equation. In my case, this is what the equation what I taken.
For example, you are running on a scenario. For that scenario, you need to provide the equation or it's all predefined.
Very good question. If you are running anything, okay, we are going to calculate the gradient now, right? There is a separate mechanism available in the machine learning. We are going to take the 2 into gradient into dx. We are going to take it. We will try to see that one. What is that? Now, okay.
Sir, quick question, sir. Sir, if we could find the x value directly, why are we going through the gradient descent function?
Sorry?
If we are able to find the x value directly, like, find the differentiation and equating to 0 and find the x value from there, why are we going through the gradient descent function?
No. You are able to find out this x value directly by using the pen and paper, not programmatically, right?
It's not programmatically, but yes. But we could do that, right?
How can you do that?
Finding the x value, find the differentiation, then
How will do the differentiation?
have to equate. Yeah, that is true though. But still, it's possible, right? The same way this gradient descendant has found it, right?
That is possible. This is what the manner. You are saying something is possible. You are saying, right? This is what the process.
So probably he wanted to find out the real-time scenario where we might have a complex function, right? Complex equation. Where you really cannot manually calculate x value. That is where we may use. Correct me if I'm wrong.
No, even if manually are able to calculate also, we are not here to calculate the manually that one. We want some program. Today I may be giving f of x is equal to x square, or tomorrow I may be giving f of x equal to x cube. Day after tomorrow I may be giving f of x equal to x power n plus x power n minus 1 plus x power n minus 2. Like the number of things I given, still it has to work it. That's what they come up with. The gradient descent is the one function they come up with. For that they written some program they written. Okay, anyhow, this program is validated in different languages also. Okay, Scala and Java, different programs also available here. So this is a static one. I mean, I can say it's a proven one. We should not question on this one. We need to understand how it is, how to write it. That's it.
So, sir, what you're saying in real life scenario, real work scenario, the equation keep changing for different data sets and
Of course,
the
of
gradient
course.
will be calculated automatically. That is what you.
Exactly.
I think when we see the real scenario, then we will get to know.
Yeah, we are going to see that real scenario now. Now, from the above steps, now what you understand theory is if the slope is positive, going opposite the slope means moving to the lower numbers. Subtract the slope from the current value directly if you do it, then it's a problem. What is that? Longer step will get it. To avoid the problem, too big a step might lead to actually miss the actual minimal point we are going to miss it. Solution is to use a learning rate. The learning rate is nothing but gamma. 0.01 whatever you take, that is what called as gamma. That is what called as our step size multiplier. Step size multiplier. Now update each weight by subtracting learning rate into what our slope we calculated. So first we have to calculate slope, Then we have to multiply with the learning rate. This one we have to use to subtract from the weights. That we'll try to do for this diagram. We'll try to do it. Tomorrow we'll calculate the slope and how to improve the model weights. Using the gradient help, we'll try to see tomorrow that piece. Okay? Any questions? So if time permits today, just walk through this one. Yeah.
Yeah, as you said, you will be working on huge data loads, right? The data will be huge. So you said you will be breaking the data into chunks, or importing into data frame or anything.
Okay. I didn't get you.
So how you are working in huge data, right?
Question is related to this one.
More than working in a real-time scenario.
Question is related to this one.
A little bit, sir. Not really.
Okay. We'll take this then offline. We'll take it. Okay. Right.
Yeah.
Come to classroom tomorrow. We'll take it offline.
So basically, this